Simply storage. Cache. Having cache is great. No, not that kind of cache. The kind of cache we're covering is a special allocation of computer memory that improves your data storage performance. Cache can be used for both reading and writing data, and special algorithms can make it even more effective. Like everything else, however, cache does have potential drawbacks. What does cache do? Well, imagine your storage device as a warehouse, only it stores digital data instead of boxes. When you go to a warehouse to drop something off, do you want to wait around until the item is buried deep inside the warehouse? No! It's much better to drop it off at the loading dock and let the warehouse folks worry about getting it stored away inside. In the same way, if you're going to a warehouse to pick something up, wouldn't it be better if it was ready and waiting for you at the loading dock, rather than having to wait for somebody to go dig it out of the back of the building? So to finish the analogy, think of cache as the loading dock for storage devices. As fast as most permanent data storage devices are, and they are fast, it still takes time to use them. Now it just so happens that some computer memory chips can read and write data much faster than your average disk drive. Users could write and read data on these chips at super fast speeds, and a storage controller could slowly push the data out to an actual disk drive as a background operation. This is the essential function of cache. How does it work on read operations, for example? Well, say a request comes into a storage device for some data. This data is retrieved from the disk, then passed back to the requester. But in a cache environment, that data would also be copied into the cache memory. Then, if another request came in for that same data, it would already be available in cache, and the system wouldn't have to waste time retrieving it again.